Hello, everyone. This is Junyao Chen. Our research is about improving learned index structures. Zoe Basnet is my partner, and our mentors are Professor Torsten Su and Jerry Go. This is a combined area between machine learning and information retrieval. Our goal is to improve the accuracy and efficiency in information retrieval systems using machine learning models. The traditional solution before the emergence of transformers or AIs is exact keyword matching. On a very high level, the system is trying to syntactically find what you ask for. But the problem or the drawbacks with the vocabulary exact match approach is that there can be vocabulary mismatch problems. Suppose you search for how many people live in Rome, likely the document B will be returned because there are more keywords are matched. But if you see closely, document B doesn't tell you anything about how exactly many people live in Rome. Instead, document A, where the vocabulary population refers you to the right answer, actually. So from this example, you see there is a semantic gap between a query and a return document. That's why there are machine learning approaches that can close the semantic gap. Our research project builds upon DeepImpact by Antonio Mandila, a previous PhD student of our professor. It is a model that learns relevance scores for each terms in a document. Using this model, we create inverted index data structure underlyingly for all documents and store relevance score of each term. Then whenever a query comes in, we look at the terms that appear in both query and the document. The score of the document for that query is the sum of the relevance scores of each terms that are in this intersection. Again, since we only look at the intersection terms, DeepImpact would still face the problem of vocabulary mismatch. So Antonio used a method called document expansion to alleviate the vocabulary mismatch problem. We use large language models like BERT or T5 to predict the possible queries for each document and append it to the end as part of the original document in the preprocessing period. This helps solve the vocabulary mismatch. The model Dr. Query takes in a document as input and outputs some predicted queries. We call the concatenation of document and the query as expanded documents. The expanded documents is then turned into index in the database, then using traditional search method at the query time, as I introduced before. The problem with the large language model like BERT to expanded documents is that they are prone to hallucination, meaning that they can make up irrelevant facts about a document, which decreases the accuracy. So our current solution is to use another model called ELECTRA that trained to distinguish between the relevant and the non-relevant queries. Then we designed on the threshold score to filter out all the predicted queries that are irrelevant. Our implementation about DeepImpact and the new filtering using ELECTRA actually relies against on MRR, which is a evaluation matrix related ranking. On the other hand, for the matrix in recall, we didn't get much changes. So recall in the expanded query pipeline, we used to predict query given the document using BERT and a T5. Now we are trying to use other models, newer models such as a BERT or Llama, to see if there is any improvement. That's all. Thank you.